In this lab, we'll observe the motion of a wallet that is dropped from rest straight down. We use the program tracker to analyze this force due to gravity. Our time is plotted on the t-axis, and our position is plotted on the x. The mass of the wallet was 0.212 kilograms. Our initial conditions are shown here. Time equals 0, position is also a 0 vector, and velocity is a 0 vector as well. Our forces include the momentum principle, which here it is the weight force, mass times the gravity, which was calculated to be 2.078 newtons. That is just the magnitude. With the direction, we have the vector 0, negative 2.078, 0. Our net force is shown here as the weight force plus the drag force, which we will discuss later. In the drag force, our proportionality constant, B, was calculated to be 0.03 to fit our data the best. If we go to the program, our initial conditions are shown here that we just stated. Our delta T is small enough to where our results will be accurate. Our G in the weight force is our gravitational force in 9.8 meters per second. Here's our direction and the proportionality constant, B. If we go to the calculation loop, this trial was run in between 0.542 seconds. Here is our momentum principle here as the weight force, our total force combined with the weight force and the drag force, and here is Newton's second law with our predicted velocity and our predicted position. We also have arrow scales here to show the direction of the force as our program runs. If we run our program, our graph of the predicted values are shown here, and also our weight force is shown as this arrow, but we do not see our drag force arrow because the wallet is too heavy. Our drag force appears to be negligible, although it is still there. If we go to our graph, it is a position versus time graph. Our observed position is shown in blue. Our predicted position with the drag force is shown in red, and our predicted position without the drag force is shown in green. Our graph appears to be shifted because, as we see over here in our observed position data, we have a few values that are still at the 0 vector as time proceeds. So our observed position graph shifted right just a tad bit, although our predicted position with and without the drag force tended to remain quite the same until we get in further time. The predicted position with the drag force is closer to the terminal velocity because the terminal velocity includes both the gravitational force and the drag force. So that is shown, it is also closer to our observed position. If the object had been thrown, the terminal velocity would be different because an additional force would have been added. Then the drag force would change in order to maintain a net force of 0. All in all, this model did follow Newton's second law and the momentum principle, disregarding variations due to human error.